Hi everyone, it's Brandon. I'm back. Today's lab is on MySQL, and every student is given access to MySQL database through your CSU CS account. So basically, what we're going to do today is talk about how to get access to this, and then we're going to do a few sample MySQL queries. For those of you who don't know what MySQL is basically the traditional database, and many of you might not have worked with databases before. But basically, databases, let's see if we can find a good example here. That's probably not going to help. Basically, databases are these structured things that allow you to store data in a really efficient manner and retrieve it in a very efficient manner. They have optimizations underneath that make them much better for updating and deleting and accessing and querying, which is the typical term you use with databases, which is getting the data out. They're organized in such a manner that it makes this very easy. Now, I'm not going to go completely over what databases are and how they work. There's something that you can Google pretty easily and learn, but basically MySQL is a relational database system. And so what that means is maybe we'll do an example later, but basically what that means is that there's going to be several database tables, and you can think of a table as like an Excel spreadsheet, just for your mental image for now. And a table basically has some columns and some rows. Let's do an Excel sheet, and I'll show you. Basically, there's columns that are named, so like attributes of the data, and then there's rows, which are data entries. So we'll create like an Excel sheet, and then we'll make a database table of what that sheet would look like. So, for example, let's say that we have a database table that's called books, okay? And I'm gonna maybe zoom a little bit. So this is, yeah, it's Microsoft. Okay, so we have our books database, right? So now, for columns, right, in this database, you're probably gonna have a title, an author, what else with books, an ISBN number, and maybe a description. There's all sorts of attributes that go along with it, how much it costs. So let's say you're creating a website like that sells books, like Barnes and Noble website or something. Okay, and let's say the first book is, let's see, I have some books over here. What about The Great Gatsby? It's a book, right? I think that's F. Scott Fitzgerald. 1, 2, 3. Let's say a good book, and it costs $20 or something. Another book, Taming of the Shrew, Shakespeare. Old book. This one's less expensive, let's say, and then let's come up with one more. What is the why am I blanking so hard right now? The Giving Tree. Who was the author of that? I'm probably wasting your guys' time doing this, but it's for educational purposes. Shel Silverstein, right? Yeah, Silverstein. Okay, and children's book or something. And this is this is $15. Okay, so here's an example of like some data in a tabular structure, right? We have columns, which are the data attributes, so the title, the author, the ISBN number, the description, the cost, and then we have some rows, which are actual entries that fill out this data. So let's go ahead, and I'm not a MySQL expert by any means, but I have the basic understanding of databases. So let's go back to your lab. And before we get into creating all this stuff and querying database, let's actually get access to our database. So first thing you want to do is, now that we're remote completely, I'm not in my VPN right now. For some reason, the VPN doesn't help you log into this database, but as a result, I'm just going to SSH into a lab machine. So Olympia is my personal favorite. So I'm going to SSH into Olympia. Okay. I spelled that wrong, that's why. Okay, so I'm in Olympia. So I'm in the computer science lab right now. So now what we need to do is go ahead and let's copy this command. Okay, true. So basically the command that we had was this, right? So we need to do MySQL-u for user. My username is Brantar. Your username is going to be the same thing as the name you use to log in to the CS machines. So it's your EID. And then D is for the database we want to load into. Everyone has a database created that is under their name, and you have privileges to that. And then the host. Our CSU CS database server is located on fower.cs.colstate.edu. You can just type Fower and it'll know where it is. And then P for password. So U for user, Brantar, capital D for database, which is titled Brantar, and then capital H for host, which is Fower, and then P for password. And then the first time you log into this, your password is just going to be your CSU ID number. Now, I have already set up my database in the past, so my password is changed. But nonetheless, so now that you're logged in, the first thing you want to do is change your password. So, I really don't want to complete this command and mess up my password. But so you do set password and then password and then in parentheses, quotes, what your new password will be. Obviously, I'm not going to do this right now because your password will be in clear text, so just be aware of that. But you can do set password equals password. Now, if you forget, you can always I just Googled CSU CS server or CSU MySQL reset password. And then I went to how to change, or no, not that. I went to like the Q&A and I just said Command F for password. And down here you can see that. So it's set password equals password, and then you do password in quotes. So that's the first thing I would do, because otherwise everyone else is going to be able to access your thing if they know your CSU ID. All right, so now we're in MySQL. So MySQL's got this interpreter. You can see it says MariaDB, which is an implementation of MySQL. And I'm going to do \h for help. So it's got some shenanigans. Okay, that's not super helpful. Okay, so first thing we're going to do, let's see if this will work. Show databases. So there are a few databases that I have access to. I have access to Brantar, CT310, this test database. CT310 is one that I was working on for the class examples, but there's nothing in there. For now, we're just going to use my Brantar database. So inside of each database, there's some tables. So if I do show tables, you can see that it's empty. So what we want to do right now is let's create a table called books. Okay, I think we need to give it a schema. So let me reference the lab. Create table, and then, yeah, so we have to give it some information about what this database is going to look like. So here's our, let me make this full screen, rearrange it. Okay, so here's our books thing that we were doing, right? So we have a title and author, so these are strings, ISBN number, which is an int, a string, and then an int for cost, let's just say. So we'll create table books, has a title, which is an int, title not int, sorry, I'm spacing varchar. So varchar, this thing stands for variable character string. So it's just a string, but for some reason it's called varchar. And then 256 is the amount of, I believe, bit the amount of bits can be used, or bytes. Maybe it's 256 byte string, whatever it is. I think that's possibly the length of the string. So you have an ID, or sorry, another thing, we have a title, that's a string. We have an author, that's also a string. We have an ISBN number, which is an int. We have a description, which is another string. And then we have, what was the other thing? A cost, which is an int. Okay. And then you have to end it with the semicolon, right? Okay, so I've created this table, so let's do show tables. And then I believe it's schema. Huh. Well, let's see here. MySQL get schema. So schema is the scheme, or the basically what we just typed in, which is the structure of our data table. Oh, here we go. It's just called describe. That's very simple. Okay, describe what this table looks like. So we have a field author, our title, author, ISBN, description, cost. They can be null. This key stuff we'll worry about at another time. But basically, we have this database table. Okay, so now we need to add some entries to it. So let's see, back to this example. This example is slightly different. I'm just using it as a guide for myself. So insert into books values. My iPad just thought I said, "Hey Siri," that's funny. Insert into books values, and then we need an author. So first things first, the Great Gatsby. Now obviously this process of manually doing this is tedious and seemingly ridiculous to someone watching, but these databases, like anything we do in computer science, right, there's going to be some automated system or user interface that allows us to do this way easier. But for now, I'm just showing you so that I can give you a demonstration. Okay, so now I've inserted one entry into the table. Now, let's do our first query. So we've created the table using create table and describing the attributes that are going to go into it. Now, and we've inserted a value into the table. So basically, this is respective to this, right? So the first thing is title, second thing is author, third thing is ISBN, fourth thing is description, and fifth thing is cost. You can see the strings are wrapped in quotes. They can be single or double quotes. I was just using single quotes. So now, a typical query statement looks something like this. Select, so you want to select something from books, right? So books is the table we want to select from, and then we say which things we want to select. Title, author, ISBN, description, cost from books. So there we go. We only have one book, so it shows us this one book that we have. Now this is obviously kind of tedious to type all these out, so there's a shorthand. Select star just says get all the columns from books. Cool. But we don't have to get all the columns. We might just want to see what authors we have. So select author. And we have Fitzgerald. So let's insert another thing. So let's do this. All right. Taming of the Shrew, Shakespeare. 3, 4, 5. Okay. Now we've got another thing in our table. So let's select authors now. Now we have Fitzgerald and Shakespeare. And we'll enter this last one. All right, almost there. All right, so we've got 3 books in our table. So let's do a select star from books. It shows the things we have in our table, right? We can also select title from books. Okay. And let's go ahead and add one more book by Shakespeare. So let's do Julius. I don't know how to spell Julius, so we're just going to do Hamlet. Okay. So let's start from books. So we've got Taming of the Shrew and Hamlet. So we've got 4 books in here. So now this is a good opportunity for me to show you. Select, let's say we want to select all the titles that Shakespeare has written. Select title from books where author equals Shakespeare, like this. And you can see now we get Taming of the Shrew and Hamlet. Now instead of select title, we could do select star and get all the entries. And there we go. So this where statement gives us the opportunity to kind of filter it out. So let's say we had an ISBN number and we wanted to figure out what book it belonged to. Let's just select the title and author. We want the title and the author for the book where the ISBN number is equal to 345. Or let's do 1, 2, 3. You can see that gives us the Great Gatsby. So this is useful, right? Because we can query based on partial information. We don't need to know everything, right? Or we just want to get the books that are written by Fitzgerald. Or let's say we want to count. Let's think of the proper way to do this. I think it's select count from books. Let's see that. Okay. So you can, I'm not, like I said, I'm not an expert on SQL, so I'm not sure what, accidentally logged out. Okay, count books. Let's see what happens here. Let me double check this. So you can, SQL is super common, so you can look up all the things. Count star returns the number of rows in a specified table. So let's see, count star, count distinct, which is, so for example, right, count star just gives us all the rows in the table. So there's four entries, right? So the number of rows is 4. So if we do select star from table, from books, you can see we have these 4 things. And by the way, I don't think you need to use capitals. It's common practice, you'll see in a lot of SQL, that the keywords are capitalized. Like this, and then like variables aren't. Oops. So the reason for that is just so you can distinguish what is the like variables and what are keywords, basically. So it's just to make your SQL queries more readable. Now, when you're just manually doing it like this, right? It doesn't matter because they're just one-off queries, but when you're writing in your code, it's not a bad idea to make the keywords capitalized. Okay, so let's say we wanted to count all the books by Shakespeare. Or we want to count the number of different authors we have. We can do select count author distinct. Hopefully this works from books. Distinct. Hold on a second. Oh, sorry. Distinct has to come first. And now you can see we have 3 distinct authors. Let me just capitalize this to make sure it works capital too. So we want to count all the authors. Distinct means don't count the same author twice. So if it won't count Shakespeare twice because he's already in there. So it's basically all however many different authors we have, right? Because we don't want to recount the same author twice. So we use count distinct. Now, we can also say how many books, we want to count all the books, count star from books where author equals Shakespeare, right? So we want to count all the books that Shakespeare has in our database, right? That'll give us 2. So we're filtering for books where the author equals Shakespeare, and then we're counting them. So you can see already that this is going to be actually really helpful, right? Because all of a sudden, instead of like if we had this file, we would have to read through the whole file every single time. And as it gets really big, this becomes incredibly impractical. Whereas the database is super, super powerful, and they're super common in almost every computer system in the world, right? And there's all sorts of libraries for interacting with them, right? Some of them, since it's kind of command line, you can write code that interacts with it. There's things that will log in on your behalf, or there's connectors, and Fuel has super good backend that supports you connecting to your database, which is what we're going to be doing in the next lab. But for now, I wanted to give you a flavor of how this works. So let's do a few more queries, and then we'll be done. So you can also you can delete things from the database. So yeah, if you look through this, this is an example of creating a database of students, right? But let's do an update first. So let's say Shakespeare books have become more popular, and we want to update all the Shakespeare books to have a cost of $15. We can do update. Let me move this out of the way. So let's look at this example right here. Update. So we want to update books, set cost equal to 15, where author is Shakespeare, right? So we're updating the books table, and we're setting cost to 15, where the author is named Shakespeare. So let's execute this query. And it says 2 rows affected, 2 rows matched, and 2 were changed. So let's do a select star to see what it looks like now. Now you can see that all our Shakespeare books are $15. We can also do and these where queries are very powerful. You, for example, could select books where ISBN, since ISBN is an integer, greater than, let's try this. Yeah, so we can select all the books where the ISBN is greater than 123. Right, so in this is not super useful, but let's update these Shakespeare books to be even cheaper because no one's buying them, right? And let's update this Silverstein book to be $8 or something. So we want to find all the books that are like for, let's say we have a discount section in our web app or something. We want all the books whose cost is less than $10. We can do select star from books where cost is less than 10. And this will give us all our books that have less. So it's super powerful, right? Because you, in your web applications, can do these really expressive queries on your data without having to open files and write to them, right? Or like if we were to do this with a file, you'd have to open the file, read every line of the file, and then you would have to determine which books were less and which weren't, and then if they updated it, you would have to rewrite the whole file. This database thing is super powerful because it's persistent and it's easy to access. All right, so now we've got that. So let's look at our table again. Cool, so let's delete this. Let's say we no longer have this Silverstein book. We're sold out and we don't want to advertise it. So delete from books, or author, or it's probably more correct in these things to use the ISBN, right? Because the ISBN is unique. So we know we won't be deleting multiple things. So we remove that row, so now you can see we just have 3 books. Now, okay, keys. We'll talk about keys in a second. Let's go ahead and do this. Let's say that let's do this alter table operation, and then we will do we will update the schema for the database and all that. So alter table. So we can also say, like, let's say description is not really useful to have in our table anymore. Something like this. I have to reference this because I don't know all the queries by memory, but this example on the lab is very useful. It shows you a lot of basic queries, and then you can always Google, like, oh, I want to select things based on this, and usually someone has some answers for you. So let's alter table, drop column. So we want to drop column description. So we're going to get rid of this column. So let's see what happens when we do this. 0 rows affected. Okay, I don't know what that means, but now, see, we no longer have a description in here because we just used alter table to drop. We can also alter table and add a column. So let's say now we're going to start counting how many of each book we have because we're an online store and we need to keep inventory count. Let's see what I did wrong. Add column. Oh, we gotta say what it is. So count's gonna be an int. The default is 0. So let's look what it is now. So I guess that doesn't really make sense. So let's do update table books, set count equals to 1. We don't need to say table, so let's get rid of that. So let's set all the counts to 1 because they probably should be 1 and not 0. Oops. So now they're all count 1. Cool. So next thing is, so we dropped a column and we added a column, right? So now we need to talk about primary keys. So let's do this first. Oh, we're gonna have to do some typing. That's fine. Okay, we're gonna drop table. Drop table is very dangerous. Be careful when you use it. Drop table deletes the entire database table. Drop table books. Now, if we do show tables, you can see it's gone. All right, so let's do create table books, but this time we're gonna change the schema up a little bit. So we're gonna have ISBN primary is gonna be the primary key, and I'm gonna explain to you what this means in a second. But basically, primary key means that it's a unique identifier for each one of these books. So each book has to have its own specific ISBN. All right. And then we have, obviously, title, varchar. I'm sorry, I got to type this out again. Author, varchar 256. And then we're going to do cost, int, count, int, right? And Obviously, this ISBN has to have a data type associated with it. Boom. Sweet. Let's see how this works. Add a semicolon, create that table. So let's see. Let's see how this thing looks. So the important thing at these primary keys, first thing is they can't be null. So every item has to have an ID. It can't have no ID. So let's go ahead and add some things into our database. So insert into books, values, and one way to do this is you can actually string them together. So we can insert all of them at once. So it's ISBN's the first thing. So it's 1, 2, 3. Great Gatsby by Fitzgerald. The cost is $20. And the count, we're going to have 3 copies, let's say. Hold on, let's see what's happening. We have an error. So ISBN's an int, Great Gatsby is a varchar, author is a varchar, cost is an int, count is an int, right? So let's double check. Insert into values. You have an error in your syntax. Oh, insert spelled wrong. Okay, so cool. We've done that, but now we can also insert several things in one line. So let's do 2, 3, 4, and this was, we got Taming of the Shrew. And that's going to be $10. We're going to have 5 copies of that. Then if we do a comma like this, we can do 3, 4, 5. We can just keep going. So now we have Hamlet by Shakespeare, let's say, and $10, 4 copies. I'm just making numbers up here. 4, 5, 6, and this will be Giving Tree by Silverstein, and that one is $8, and we have 2 copies of it. Okay, so we've just inserted 3 rows at once. So let's do a select star from books, see what we've got. Okay, so here's our table, and ISBN is our primary key. So now, see, what's interesting here is this example doesn't really show you how powerful the primary key is, but let's say we were to create another table, right? We want to create book descriptions because these descriptions are long and maybe we don't want to include them in our database, or maybe they're related to a book. Or let's do this instead. Let's create table of sales, right? So sales aren't necessarily related to books, so we don't want to keep them in the same database table, but we want to be able to track the people who have bought books by their ISBN number. So we have ISBN int primary key, customer name, which is going to be a varchar 256, and then the cost, the amount we sold it for, or something, right? And that's going to be an int. Okay, so we've got this other table called sales. So now let's say that someone bought a copy of Hamlet. So Hamlet's ISBN is 345. There we go, Hamlet. 345, the name of the customer is a big fan, let's say, and we sold it for $10, which makes sense, right? Because that's how much it's charged for. So now, if we select the things from our sales, we have this one entry. But now let's say that we want to know something. We want to aggregate the data across these two tables, right? Like we want to know, sorry, someone's calling me. We want to know how many people have bought a Shakespeare book. So we can select star from books, inner join sales on ISBN equals ISBN, I believe. So we will have to do books.isbn equals sales.isbn, for example. So what this says is get everything from books, and we're going to join books with sales based on all the book ISBNs being equal to the sales ISBN. So what this means is that we're taking these two tables and stuffing them together based on what books have been sold. Now, to make this even, to hammer this point home, sorry, I'm going to have to take a quick pause, and then I'll post a second part.